MooMooMath. Today we are going to talk about congruency. So let's start off with our lesson. Okay, you should be able to print these notes off the blog and just fill them in with me. A triangle has three vertices. The vertices of the triangle are, well, let's look at this one. We have a triangle RUN. Vertices just means the corners or where two sides meet. So our corners are angle or R, U, and N. There are these points on the triangle. The triangle also has three sides. The sides of the triangle are UR, and that is a segment. RN, that is a segment, and NU. And again, that NU is a segment. The triangle also has three angles. Okay, so the angles are U, R, and N, and we name those angle U, angle R, and angle N. So another way to name the angles is with three letters. So if I want to name this angle at U, I can name it R, U, N. So angle from R to U to N. I can also name it backwards, N, U, R. Okay, this angle up here at R, I can name two different ways, U, R, N, or N, R, U. So let's name that one N, R, U. And notice the vertex is in the center for each one of these. And then this last angle over here, N, I can either name R, N, U, or U, N, R. So I just picked one of those. Okay, to name a triangle, you put a triangle in front of three letters that are the names of the vertices. So we can name this triangle RUN, or we could name it NUR, or we could name it URN, and of course I can also name it backwards UNR. So just as long as you use your triangle symbol and then the three letters. Now because this is just a triangle, we don't have to worry so much about the order, because if you start at R, go to U, go to N, start at R, go to N, go to U, it's still naming a triangle. When you get a quadrilateral, you must go in order. Okay, so now let's look at angles. Okay, two angles are congruent if they have the same measure, and we've talked about this in class. How do you say that? You say angle 1 is congruent to angle 2, but if we actually know the length of the measures, we can say the measure of angle 1 is equal to the measure of angle 2. So this is just the definition of congruency, and you can go back and forth between the angles being congruent and the measures being equal. We can do the same thing with segments. Two segments are congruent if they have the same measure. So to name them, we can say segment AB is congruent to segment CD, and we use the symbols a segment, the congruent wave, and the segment on top. Or if we know they're equal, we actually know what the measure is equal to. We can say AB is equal to CD with no segments and congruent waves on top. Okay, if two triangles are congruent, then they must have the same measures. But how would we measure the triangle? By the measure of their angles. We must know that all three angles are congruent to each other, and by the sides. All three sides have to be congruent. So how many parts does a triangle have? A triangle has 6 parts. It's got 3 angles, and it's got 3 sides. So there's 6 parts we're working with. Now, let's look at those 6 parts in congruency. Okay, two triangles are congruent if each of the angles is congruent. If each one of the angles is congruent to each angle of another triangle. So the corresponding sides and the corresponding angles must all be congruent. So again, we have 6 parts. We've got the 3 angles and we've got the 3 sides. But in order for these 2 triangles to be congruent, all 6 of those parts must match each other. So let's look at the segments or the sides that are congruent. Okay, let's look at side AC, A to C. Which side is AC going to be congruent to? Well, A is a right angle and C is our 30-degree angle. So let's look at this triangle. E is our right angle and D would have to be our 30-degree angle. So side AC is going to be congruent to side ED. Yes, we have to name it in that order because they have to match up, because A corresponds to E and C corresponds to D. They're the 90-degree angle and the 30-degree angle, and this is a 90-degree angle, and that's the 30-degree angle. So now let's look at another matching side. Let's say I go from A to B. I'm now naming this side, and it almost looks like the shorter side in the diagram. So over here, since I'm starting at A and going to B, and B is my 60-degree angle, I have to name it in the same order. E is my 90, and F is my 60-degree angle, so I have to name that side from E to F. Now let's look at the third side, BC. That's actually the hypotenuse of this triangle, so let's look at the hypotenuse of this triangle. If I'm starting at B and moving to C, and B is my 60-degree angle, I must name it in the same order. F is my 60-degree angle, and D is my 30-degree angle. So F to D. That's my other side. Now, let's name our congruent angles. These are a little bit easier. Okay, angle B is going to be congruent to what angle in the other triangle? Well, B is 60, so it's angle F. Angle C is my 30-degree angle, and angle in this triangle, angle D is my 30-degree angle, so they're congruent. And then this last one is angle A, which is my 90-degree angle, and angle E, which is also my 90-degree angle. So you can see that this triangle has 6 parts. And when you're matching them up, AC will match to EF, AB matches to EF, BC matches to FD. And again, the angles that are congruent, we're naming those. Sometimes people have a hard time seeing it when they're turned like this. So if it helps you, you can redraw this triangle over here so that each of the parts lines up, where angle E and angle A are at the bottom left. That would make angle F up here because it's 60 degrees, and then angle D I've rotated and it's moving to here. And then it makes it easier to look at the triangles and see the corresponding parts. So that may be a helpful hint if you need that. Okay, so now let's write some congruent statements about the triangles, keeping in mind that we have to name things in order. So let's read this. In order to write a statement saying that 2 triangles are congruent, you must put the order of the vertices in the order of congruency. The congruent statements for each of these 2 triangles can be written several ways. So we have these same 2 triangles, but how can we write the statements correctly? So if we say A, B, C, we have to name the triangle that corresponds to it in the same order. So we've already figured out that E corresponds with A, B corresponds with F, and C corresponds with D. So we would name this statement as E, F, D. Okay, now let's look BAC. So we're going from B to A to C. So I'm starting at my 60-degree angle, moving through my 90-degree angle, and to my 30-degree angle. So in order to do that, I would have to do F, E, D. So that's going to be triangle FED, from the 60 degree to the 90 degree to the 30 degree angle. And then CAB would be 30 to 90 to 60. So that would be 30 to 90 to 60. So DEF. Now, let's look at this one. How can we start at A, but then name it in the opposite direction? So if I'm starting at A now, A, C, B, I have to go from A, 90 to 30 to 60. So this one would be 90 to 30 to 60, and that would be E, D, F. Okay, another way to name this triangle, instead of going BAC, I can go BCA. So 60 to 30 to 90. So 60 to 30 to 90. So that's FDE. And this last combination, starting at C, I can go CAB like I did over here. That's going from 30 to 90 to 60, but I can also reverse it and go from C to B to A, which is 30 to 60 to 90. So D, F, E. Okay, and again, if you're having trouble seeing that order, redraw your triangle where E is in this corner. That would make F up here because it's 60, and D over here, which is 30, and then it's easier to see these orders because you've got them lined up. Okay, so that's naming. So we've named the corresponding sides in this first section. We've named the corresponding angles in the second section. And now we can name the congruent triangles, keeping the congruency in the correct order. Now, there we go. Now, let's look at some where we actually have to draw them. So we're given two triangles, XYN and triangle KLB. Now we need to draw and label the triangles and indicating the corresponding parts. So we have to look at the order. So we have a triangle, and it's X, Y, and N. Now, to make it easier, I'm going to draw another one that looks the same as the first one right underneath it, and that's going to be KLB. Now, because of the order, I know that X and K correspond, so I'm going to mark those as congruent. Y and L are also corresponding and congruent, so let's mark those the same. And then N and B are congruent. Okay, now let's mark the sides. K to L is congruent to Y to Z, or I'm sorry, X to Y. L to B is corresponding to Y to N. And then K to B is corresponding with X to N. So mark those with 3 marks. That shows me 3 sides are congruent and 3 angles are congruent. Now, what sides are congruent? Let's name the 3 congruent sides. X, Y is congruent to KL. And those are in the correct order. YN is congruent to LB. And side NX is congruent to BK. And notice all of the orders are correct. So which angles are congruent? Since we don't have any angles that have other angles coming off them, I can name them with one letter. So I can say angle Y is congruent to angle L. Angle N is congruent to angle B. And then angle X is congruent to angle K. So I have 3 congruent sides and 3 congruent angles. Now, can I name corresponding parts without drawing the triangles? Well, let's look. Without drawing the triangles, can we complete congruency statements? Well, we know we have 3 sides. We know we have 3 angles. So can we name those 6 corresponding parts? Well, I know that M and X correspond, N and Y correspond, O and Z correspond. So I can just name those 3 angles. Angle M has to be congruent to angle X. Angle N has to be congruent to angle Y. And angle O has to be congruent to angle Z. So there are my 3 congruent angles looking at the order. So what sides would be congruent? Well, MN, naming them in order, has to be congruent to XY, the first 2 in this, naming this triangle. And O, that segment, has to be congruent to YZ. And then the last one, I would say O to M, the first to the last one named, O to M, has to be congruent to ZY. So I didn't even have to, ZX. So I didn't even have to draw it out, and I can look at the order and know which 3 angles are congruent and which 3 sides would be congruent. So you don't have to draw it out. Drawing it out, obviously, is the best method, though. So let's go down here and let's name our congruent triangles. These triangles are embedded inside of other triangles. So let's look at how many triangles we actually have here. I have one over here, ABC. I have another one over here, CED. Then I have a smaller triangle at the bottom, ACD. But then I have what we call overlapping triangles. ABD, this larger one, and I have DEA, this larger one. So we have a lot of triangles going on here, but we don't want to name all those sets. We just want to name the set that's marked. Okay, so we've got this triangle ABC, the small one on the left. So let's call that triangle ABC, and it's going to be congruent to another triangle. So let's see, A corresponds with D, so I've got to name that first. B corresponds with E, so I named that second. And C corresponds to C, and we can see that's a vertical angle anyway. So there we go. That's how you would name those 2 congruent triangles. Now let's look at these. These are separated, and they're given with just lengths and measures, with actual lengths. So we have 8, 8, 15, 15, 25, 25. We can see these 2 angles are 23 degrees, and these 2 angles are 91 degrees. So I can start at any vertex. I'm just going to start with A. I'm going to call this triangle ABC. Okay, triangle ABC corresponds to which triangle? Well, A corresponds with F. And B corresponds with E. And so C and D are both the corresponding angles. So triangle ABC is congruent to triangle FED. And that's how you name those corresponding triangles. Okay, let's look at these last 2. See if we can do these. Okay, ACD, there's my triangle. And let's name its corresponding parts. Well, A corresponds with which one? C. Oops, that's supposed to be congruent. So, A corresponds with E. And I did the order as C. Well, C corresponds to itself because it's vertical. And then D corresponds with B. So triangle ACD corresponds with ECB. And the last one over here, let's see, we've got 2 triangles. And we'll name this ABD. I'm going to look at this lower triangle first. So A to B to D is congruent to, well, A up here, this triangle, corresponds to this angle down here. So that's angle D, isn't it? D, and then B corresponds to C, and then D, this angle corresponds to this one up here, A. That's a little bit tricky because we're using some of these vertices twice. But we're looking at this triangle on the bottom left, ABD, this triangle. And if you rotate it around, you can see it's congruent to this triangle DCA. That one darker. Anyway, there we go. That's how you name congruent parts of triangles. So you have triangles. They have 3 parts, 3 angles and 3 sides. So that's 6 congruent parts. So you can always name 6 congruent parts to congruent triangles.